Hi, I'm Chonghua Guo, founder of Chonghua Academy. I will teach you the primer of probability. Now we start exercise class 1 for the two kinds of principle of counting, addition-based and multiplication-based. There are 3 assignments left for you at the end of last class. Before I go to the solutions for them, I would like to spend a while to check my toolbox, which means our 4M problem-solving approach. The first M is motivation. Motivation is the reason for solving a problem or answering a question from both real and abstract world. For example, I try to pick a book from my bookshelf with motivation to relax. The second M, method. Method is your strategy to address the problem. For instance, the ways to pick books may involve either addition method or multiplication method. The third M, mechanics. Mechanics is the calculation and graphing of the answers to the questions. For example, once you have determined correct method, you just do the specific calculation such as addition or multiplication. The last M, more thoughts. More thoughts are the extended thinking of more questions arising from the original problem. I really encourage you not to stop at the answer you have figured out for the original problem. That's good, but it could be better to challenge yourself by asking more what if then questions. What if then questions. You may find you learn more and faster than your counterparts by being persistent on this approach. Okay, with 4M approach in our mind, let's look at the assignment 1. In the following 2 electric circuits, how many ways are there to connect the circuit by circuit 1, closing 1 switch, circuit 2, closing 2 switches? For question 1, what's our motivation? We can follow the our motivation is to get light by closing 1 switch. By closing 1 of the switch, and we get the what might be our method? Since closing 1 switch is a one-step job for a parallel circuit like this, and we can either close this one, this one, this one, this one, and this one like this. We may conclude that addition method of counting should apply. So addition method like this. Furthermore, we have known that the key to applying addition rule is to identify types of options to get job done. There are 2 types of here, A and B. A and B. Type A is of 3 witches, 1, 2, 3. So we got 3. This is A. And type B, 2 switches. Type B, 2 switches. So now we can move to mechanics to do the calculation, which results in 3 plus 2 equals 5 different ways. This answers the question 1. Now, can we ask ourselves more question, which is our fourth aim, more thoughts? Right here. Yes, I would like you to extend your thoughts by asking a what if question here. How many ways are there to connect the circuit 1? By closing 2 switches, you may regard the redundant switch as an assurance. For question 2, so this is for question 2, motivation now. Is to get light by closing 2 switches. Still is getting by closing 2 switches. In terms of methods, can you connect the circuit by closing the 2 switches only from B, just only from these 2, close to, or the 2 switches just from A, or 2 from these? No, you can't. You can only connect a so-called series circuit. This one is a series circuit by closing 1 switch from A and 1 switch from B. This implies multiplication method should apply here. So this time should be multiplication method. Step 1 involves in selecting 1 switch from the 3 switches of A. Either one of these. Step 2 involves in selecting 1 switch from the 2 switches of B. So mechanics, there are totally 3 times 2 equals 6 different ways. Assignment 1 gets done so far. More thoughts. How many ways are there to connect the circuit to by closing 2 switches from A, just for an assurance, and 1 switch from B? Now, let's look at assignment 2. In the following map, one of 3 colors need to be painted on 4 areas labeled as A, B, C, and D, respectively. Same color is allowed to use repeatedly. However, adjacent areas must be in different colors. How many ways are there for painting color? What's our motivation? For this problem, our motivation might be to get an easy search map with different areas painted with different colors. So our motivation is to get an easy search map. Can we determine the right method? Since areas A, B, C, D needs to be painted one by one, so we can conclude that multiplication method should apply. So multiplication method should apply. Can we further determine how many ways of painting each area is involved in? Well, the bad news and the good news. The bad news is that we have 4 areas, A, B, C, D, but with only 3 colors. The good news is same color can be used repeatedly. So look at this map. Area B and area C may share area C and area B may share same color because they are not adjacent. In such case, we start painting B as the first step, which has 3 colors to choose. So for step 1, B got 3. For step 2 is A. Let's look at area A. Area A cannot repeat B's color because they are also adjacent. So area A has 2 colors to select. Now, how about step 3? Step 3, area D. Let's look at area D. Area D cannot repeat B's color because they are also adjacent. So, and I can only use the remaining color as in after A's choice in step 2. So area D has 1 color to choose. Finally, step 4, area C. Area C can be painted with the same color as in area B because they are not adjacent, which means area C has 1 color to choose. Now, we can do the mechanics, which result in 3 times 2 times 1 times 1 equals to 6 different ways for painting color. This answers this question. Now, more thoughts. How many ways for painting are there if given 5 colors instead of 3 colors? Now let's turn to our last assignment. For all 2-digit numbers, how many among them are there whose single digit is larger than 10 digit? We still follow the 4M approach. Unlike the previous 2, this one's a little bit abstract. However, we still try to use the 4M approach to address it. So let's start the first M. What's our motivation for this problem? We are motivated, maybe by our curiosity, about how many 2-digit numbers exist with single digit is larger than 10 digit. So probably our motivation is curiosity. We'd better write AB to stand for the desired 2-digit number, and AB is the 2-digit number. 2-digit number. With B is larger than A. B, we have B is the single digit larger than A. What's the method to find it? It's a little bit tricky right here. Is this a one-step job or multi-step job. Let's do some trial. Suppose it's a multi-step job. Step 1 is to determine single digit, which means B, which appears to be anyone from 0 to 9. So B could be numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Immediately, we can see that, however, the B cannot be 0 and 1 because they are no larger than any other numbers on 10 digit. So each of candidate number 2, 3, 4, 5, 6, 7, 8, 9 can make sure single digit B is larger than 10 digit A independently, no matter how large 10 digit A is. This implies we don't need to care about 10 digit. Therefore, we conclude it is a one-step job and addition method should apply. One-step job. So it's addition method should apply. Number 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9 can be regarded as A type. So we can look at as A type. They could be 2, 3, 4, 5, 6, 7, 8, 9. Which consist of different ways being larger than 10 digit. For example, type 2 larger than 1 basically means that there is one way. And 3 could be larger than 1 and 2. So it could be 2. 4 larger than 1, 2, 3. So which means 3 ways. 5 larger than 1, 2, 3, 4. So be 4 ways. 6 could be larger than 1, 2, 3, 4, 5. 7 larger than 1, 2, 3, 4, 5, 6. So which means that 6 different ways. 8 could be larger than 1, 2, 3, 4, 5, 6, 7 larger than 7. It means 7 different ways. And finally 9 larger than all of them. 1, 2, 3, 4, 5, 6, 7, 8 means 8 different ways. Okay, so we continue to write down all the types and their corresponding ways being larger than 10 digit. Now we are ready to do the mechanics. Together there are 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 equal to 36 different 2-digit numbers. Finally, more thoughts. How many 3-digit numbers exist whose 10 digit is larger than 100 digit? Let's call this an end of our exercise class 1.